Welcome to Chapter 11, Public Key Infrastructure and Encryption. Encryption is a big part of access control. It's a big part in everything you do on the internet. You're going to have to take a class probably in cryptology, which will get in a lot more depth. But we're going to give you a good overview of how it works, how we use it, and why it's so important. So we'll start with the introduction. Encryption is part of your everyday life. So if you do anything on the website, you use it on the internet. Each time you access secure websites, conduct a transaction at an ATM, you check your email, encryption lurks behind the scenes, providing the secure transmission of information. Encryption relies on the use of encryption keys to ensure that information is only readable by the intended recipient. Distributing and managing these keys is one of the trickiest parts of implementing an encryption system, and many encryption system approaches the public key infrastructure, PKI, fills that role. So what are we going to be looking at in this week? Public key infrastructure, how integrity, confidentiality, authentication, and non-repudiation are ensured within public key instruction. We'll see what it's not, how businesses use cryptology, how certificate authorities issues, manages, and revoke digital certificates, what risk associated with PKI, and best practices for it. So we're going to do give a good overview of how it works. So public key infrastructure, PKI. It's an important mechanism for businesses and e-commerce transactions. It provides a community of trust. Through this trust, people are able to browse the web more securely, send secure emails, and download software. PKI does not solve security issues, but it does make all software safe as long as it's used websites. And it doesn't have malware embedded. However, it does provide infrastructure to make the internet safer and provides a level of security. So public key PKI is different than public key cryptology and PKI are indifferent. Public key cryptology is also referred to as asymmetric cryptology. PKI infrastructure is secure distribution of public keys that is used. And we'll go over what that actually means in a few minutes. So what is the public key infrastructure? It's the framework that consists of programs, procedures, security, policies, and it uses the standard of X.509 standard for digital certificates, which we'll get into. But components, the public key infrastructure is made up of several components: the certificate authority, registration authority, certificate server, certificate repository, certificate validation, key recovery service, time server, and signing service. So all these parts make up what public key infrastructure is. It's not just an application we put on, but it has all these different parts. So the certificate of authority is an entity, normally a trusted third party, that issues the digital certificates for identity. And basically it just means that they've verified that this website and person is real. So it helps keep everything nice and safe. The registration authority is responsible for the registration of initial authentications of users who issue certificates. The certificate server is the machine or server responsible for issuing the digital certificates based on information by that. The repository is just a database. The validation is the process of determining that, yes, this website is good, and so on. So that's kind of how it all comes together. So encryption and cryptology, PKI provides the capability to distribute public encryption keys while keeping decrypted keys private. So what is encryption? Encryption is the process of applying an algorithm to plain text, resulting in ciphertext. So this takes a Word document, converts it so no one can read it. That's all it really does, and it's run through an algorithm. So the crypto system is a combination of hardware, software that provides encryptions and de-encryption. So the encryption system is made up of encryption algorithms, keys, softwares, protocols, and the algorithms determine how the encryption and de-encryption will take place. So this is all that will do for us. Symmetric encryption. Symmetric algorithms use share keys for encrypting and decrypting. Both sender and receiver use the same key. So just think of it as when you have your house, you have a set of keys for you and one for your friend. Well, you use the same key to get into that house. It's the same concept. You both have the same key, so you have that. So the symmetric key system encrypts and decrypts information with the same key. Symmetric requires a secure method to secure that key, keep the key secret. And each pairs of users require that. So for me and you to share data, I can send you the key, you have it, and I have it. It's nice and simple. And that's how it works. Now the asymmetric encryption uses a pair of keys, related keys, a public key and private key. For the encryption key and decryption, a public key can be known to everyone. The private key is known by the end user or the owner. So if you want to think of it this way, if you have an office building, and so I have my key to my office that will only open my office. Well, guess what? The janitor has a key that will open everyone's office. So it kind of works on that concept. The janitor has the key for everyone, so he can get into the offices to clean them, but you can still only get into your one key. So it's a master key, if you want, that would unlock it. But it works the same way. It sends it through an algorithm that allows us to encrypt basic data and allows us to do it. Now the asymmetric, let's see, what is this? Different group sizes. So the number of keys needed. So if I have a symmetric key, which means I have to share that key. If I have 100,000 people, if I have 2 people in the group, we have 2 keys. If I have 3 people in the group, we have 3 keys. If I have 5 people in the group, well, now I have 10 keys. If I have 10 people, 45 keys. Where the asymmetric, for 2 people, we'd have 4 keys. For 3, we'd have 6. So in the end, we have a lot less keys we need to get going. So it helps us do that. So now, business is a requirement for cryptology. For multiple uses within the organization. Some of these include internal data, external data. And remember, when data is encrypted, no one can read it with the naked eye without having that algorithm or key to break it apart. So some of the things that allow us to encrypt data, ensure data integrity, right? Because if you can't read it, you can't change it. Ensure secure collaboration between entities inside and outside the organization. Ensuring secure cloud computing. Providing secure transactions with consumers. Ensuring software and data integrity means that the software is secure and being developed. If you're storing stuff on the cloud, you want to keep it encrypted. Now this gets us into the digital certificates. The digital certificate in key management is used by individuals, users, servers, devices, and third parties with known this. And especially this becomes really important with the Internet of Things. Digital certificates, it means that that third party verified that this company is using the correct encryption methods. So we can have different versions of the certificate, unique serial numbers, algorithms, so all these things are part of that. Registration or authority verifies that the identity of the individual initiated certificate provides with the CA. So domain validation, organization validation, extended validation. It will also help us with key generation, key distribution, key storage, key usage, key recovery, and key things. So these are some of the different things. So what's the difference between symmetric and versus asymmetric algorithms? Symmetric and asymmetric encryption algorithms varied in many ways. Just learned about a few ways can be implemented, but a major difference outside of the ones we've already looked at is asymmetric cryptology requires longer keys in order to achieve the same level of security through symmetric. But the 2 people who invented this was Whitfield Diffie and Martin Hellman, who did created the asymmetric cryptology in 1976, and this allows us to have this that we have. So if it's just me and you sharing data, or symmetric would be easy. But if I'm sharing it with the class, everyone would have their own key, and I would have the master. So asymmetric would work better. So it allows us to work in that information. Ensuring integrity, confidentiality, authentication, and non-repudiation, PKI system uses symmetric and asymmetric encryption algorithms and digital certificates to provide security for multiple applications. Confidentiality ensures that only the intended recipient can read the message. Integrity ensures that only the recipient of the message in certain things received it. Authentication allows someone to prove his or her identity using asymmetric. And non-repudiation ensures that the objective third party can verify that the message came and purported sender and was not forged. Now, we're going to talk about digital signatures. Now, digital signatures use something called a hash. Now, when we sign something, we want to verify that it doesn't get changed. In today's documents, if they're not printed out, well, we have this PDF file, but as you know, we can change PDF files. So we're going to use this thing called a digital signature that requires cryptographics hash function. And so what the hash function does is it takes that document, and instead of it being run through a different type of algorithm that allows it to say, I want a 32-bit output. So whether I type hash the word yes, it's going to be 32 bits long. If I hash the book of War and Peace, it's going to be 32 digits long. So I set my output range, and then what it does is it takes every piece of information on there, every period, every space, every letter, every white space, whatever it is, and it generates a 32-bit number. Now, they're much bigger than that nowadays, but just for an example. And then what happens is when I get that document, I can sign it, I send it back to the user, the originator, and I check that document. So it checks that hash, and it has to be exactly the same. If I just move the space or a period or change the word, well, that hash number is going to be completely different, and then it won't match, and I know that it's changed, and that, hey, I won't sign this or I won't accept the signature. So that's kind of how it's working. This is also a great tool for downloads. And usually when you download a file, what will happen before you start your download, a hash number is run. It verifies it. When you complete the download, it runs another hash and the number should check. If not, it will reprocess the download. So what is PKI? What is PKI and what it is not? PKI is the framework to build a secure infrastructure. PKI has a strong authentication mechanism, and it allows the users to do this. It provides a mechanism to ensure that what was downloaded or read has not been altered. PKI provides integrity, confidentiality, authentication, and non-repudiation, and a single framework. Let's see. It is not the answer to your security concerns. You cannot encrypt all your data and communications and assume that everything is fine. Security within the organization requires multiple layers, and PKI is just one of those layers. PKI does not provide authorization. It may authenticate, but it doesn't provide that. PKI does not guarantee that the end user is trusted. So these are just some of the things that we have to keep in mind. What are potential risks? There are multiple risks that we could have to deal with. If PKI management is mishandled, the system can fail. Managing a secure environment with multiple keys and multiple entities can be overwhelming and challenged. Risks associated with it comes in many forms. Implementation for business cryptology. This comes as part of one of the OSI transport layer, OSI in the NIC cards, 7-layer process. And it is the encryption uses the cryptograph to ensure that communication between the points of parties or authentication. Cryptology, encrypting hard drives to prevent measures, encrypting removal devices, encrypting instant messages, encrypting files, encrypting databases. These are some of the things that businesses should keep in mind. Certificate of Authorities, or CAs. This is a third party that verifies that the digital certificate implementation is done through a third party, and they will verify. They will policy authority responsible for establishing, distributing, maintaining, promoting, and enforcing these. Certificate manufacturer generates and manages this digital certificate asymmetric key pairs. Certificate user distributes these. Revocation manufacturer generates and maintains of the expired keys. Best practices: implementing a PKI use within the organization requires much thought and planning to determine how capabilities will be used. The important to understand why you need a PKI in the first place and the impact it will have. What are the business drivers that we're going to need? Are you implementing it for e-business, requiring it for integrity, confidentially? What applications might you use? What architecture might you be using? The impact will implement have on users and customers. Can the current organization infrastructure work? What are the legal policies we need to look at? Who will have the access to the system? So these are some of the things that we want to look at. So let's have a chapter summary. Basically, we discussed symmetric and asymmetric encryption algorithms and how they're used with the public key infrastructure. We looked at the risk associated with maintaining key management and certificate authorities in-house and outsourcing them. You reviewed the security services that provide through the various PKI functions and how each of them functions individually. Understand these concepts will assist you in understanding that technology. That kind of gives you an overview of what encryption does, PKI infrastructure and encryption. Thank you. Have a wonderful evening.